Hi, thank you for having me. Can you please introduce yourself?
Sure. Hi, everybody. My name is Lea Hirsch. I am a professor in the Chemical and Physical Sciences department. I teach astronomy, and I've been at UTM for about 2 years. And I teach many of the sort of introductory level astronomy courses that you might take as a student at UTM.
What courses you teach?
I teach Astronomy 101 and 201, which are sort of general interest astronomy courses for large audiences of students. And then I also teach Astronomy 221 and 222, which are the introductory astrophysics sequence for astronomy majors and specialists. And as of last year, I also teach Astronomy 252, which is called Life in the Universe. It's a really fun interdisciplinary course about astrobiology and extraterrestrial life.
Oh my God, that's cool. Tell me about your educational background and where you studied.
Okay, I did my undergraduate degree at Cornell University in Ithaca, New York. My graduate degree was at University of California in Berkeley, out in California. I stayed on in California for a postdoc position at Stanford for about 3 years, and then I came here to be a professor here.
What was your PhD thesis about, and why you thought you are interested in doing research?
Sure. My PhD thesis was about planets, exoplanets specifically, so planets orbiting stars other than our own sun. So I searched for planets orbiting some of the nearest stars to our own sun, and tried to understand the effect of stellar multiplicity on planet formation and evolution. So that's basically systems with multiple stars, comparing the statistics of planets that orbit around one of two stars in a single system, in a binary system, to the properties of planets in single star systems, to try to understand the effect of binary companions on the planet formation and evolution process. So that's what my thesis was about. And I actually got into astronomy and really decided I wanted to go to grad school and study astronomy because I took a lab astronomy course as an undergrad. So back at Cornell, we had this class in my third year where I got to develop and then go take observations for an observing project. And the project I picked was trying to find the transit of an exoplanet. So I was able to identify a good target and go out and collect data and then analyze the data and discover the dip in the brightness of the star that was caused by the planet orbiting in front of it. And that really that excitement of that experience really solidified my desire to go to grad school and do research in astronomy. And it also really set me on the path towards studying exoplanets that I continued on in grad school and as a postdoc.
Interesting. How would you distinguish doing research in astronomy versus other fields?
Oh, that's a really interesting question. I think astronomy is quite unique, especially observational astronomy, in the sense that it is one of the only fields where you are completely at the mercy of the Earth's atmosphere, in a sense. So a lot of nights I would go out to try to collect observations as a grad student, and it would be raining or there would be a fire nearby or something would be going on, and it meant that you just couldn't collect your observations. And so learning to sort of deal with the disappointment of sitting at a telescope with the shutter closed and the dome closed all night was something that was quite unique to research in astronomy. And also I think astronomy is unique in the sense that you can't really go to a lab and design variations on an experiment. So the way that we learn things in astronomy is just by looking at the light that those distant objects release. You can't really tinker with the observational method that much, so you have to be really clever about how you learn things based on just the photons that are reaching you.
What are some skills that are needed for students who want to do research in astronomy?
I would say modern astronomy research relies really heavily on coding and statistics. And those are skills that we often don't teach students in the classroom, or at least not formally. So learning how to use Python especially to analyze data, and then learning the very applied version of statistics that we use to sort of fit models to data and understand the uncertainties in our data and our models. Those are skills that are really, really important as you go on into astronomy research. Especially modern astronomy research is so often very much on the edge with data science. And so understanding how to deal with data and how to analyze data computationally is really, really important.
Are there any opportunities for undergrad students that can do research with you?
There may be. So I typically host a couple of ROP positions during the summer. So this summer I have 4 ROP students working with me. Last summer I had 2 ROP students working with me, including Tabasom. And then potentially during the year, there are courses like CPS 489, which allow students to do research at sort of like the senior thesis level, which I would be happy to talk to students about projects for those types of classes as well. Downtown, there are the Astronomy 424 and 425 courses, which students in astronomy here are able to enroll in, and I have also supervised students through those courses as well.
Amazing. Are you happy with where you are right now?
I am. I really enjoy that I get to teach so much here at UTM. I really liked doing research, but honestly, I really like teaching even more. I really like engaging with students and like seeing the aha moments that they run into and like enjoying them learning things for the first time. Sharing astronomy is one of my favorite things, so I'm really happy that I get to teach lots of courses here and interact with students a lot, and that has been a really special thing for me being here.
Do you have any final suggestions for students?
That's a good question. I would say try things, I guess. Be brave and like try new things. You know, talk to new professors, ask them about their research. People are really happy to talk to students generally. Go to office hours, take advantage of the opportunities you have to interface with your profs. Meet us. We want to talk to you.
Thank you so much.
Sure. Thank you very much.